When it comes to power dissipated in electric circuits, there's a common doubt. Does the heat dissipated increase or decrease with the resistance? Why do people get this doubt? Because there are two formulas for it. One is V squared over R, and the other one is I squared into R. So one makes you feel like the heat should reduce with resistance, and the other makes you feel like the heat should increase with resistance. So what's going on? By the end of this video, you'll have a complete, clear idea of what's really going on over here. What generates heat? Why does the power dissipate in the resistor in the first place? Where does that come from? So what's really happening is that the electrons are colliding with the atoms, making the atoms jiggle. And every time the atoms jiggle, that's when you have heat generated. What decides how much heat gets generated? Well, think about it. What decides that? Well, the more atoms jiggle, the more heat you get. So the question then is, what makes the atoms jiggle more? Well, the electrons are colliding with it. So one of the things would be with what energy the electrons collide with the atoms. Because every time the electron collides with the atoms, it transfers energy to it. If the electrons have more energy, then they're going to transfer more energy, making more vibrations, giving more heat. So let's write that down. Heat depends on the energy of the electron. But what else matters? Well, remember, this is not just heat, it's heat generated per second. That's what we mean by power. So I need to also worry about how many electrons are colliding with my atoms per second. If you have twice the number of electrons colliding with my atoms per second, clearly twice the amount of energy will be transferred per second. And therefore, the second thing that matters is the number of electrons colliding per second. And so if you put this together, the heat generated per second actually is a product. Depends on the product of these two. And if you look at it, it kind of makes sense, right? You have energy per electron, and then you have number of electrons per second. The per electron, the electron over here cancels, and it sort of gives you energy per second. That's basically the heat per second. Okay, with just this intuition, now let's see what happens when our resistance increases. So how do we increase the resistance? Well, let's make a copy of this circuit. Let's put it down over here. And the easiest way to increase our resistance is just to make it bigger. That's the beauty of digital boards. All right, so I've made my resistance bigger. Just from this, I want you to pause the video and think about what's going to happen to the heat generated per second in this circuit. Don't use any formula, just use the intuition that we've generated. All right, it's fine if you don't get it right. The idea is to have some explanation for what you think is going to happen. All right, so first step, what happens to the energy per electron? Okay, for that I'm going to ask myself, what does the energy of an electron depend on? Well, the energy that the electron gains in any circuit depends on the power source. It's the power source that's pushing the electron and giving energy to it. In our case, the power source is the battery. Battery is giving energy to the electrons. Has anything happened to my battery? Nope. The battery has stayed the same. And therefore, nothing changes with my energy of the electron. The energy of every single electron stays exactly the same. So this stuff does not change at all. But what happens to the number of electrons that are colliding with my atoms in the resistor per second? What's going to happen to that? If your resistance in the circuit has increased, but your battery, the push has stayed the same. So what is going to happen to the current? Well, the electrons are going to flow a little slower now because they get the same push, but there's more resistance in the circuit. So electrons are going to have a harder time, and so they're going to go flow slower. And if they flow slower, then the number of electrons that are going to collide with my atoms per second, that's going to reduce. Does that make sense? And therefore, in my new circuit, where I've increased the resistance, this thing is going to go down. The number of electrons per second, that's going to reduce. And therefore, what's going to happen to the heat generated per second? Well, that's also going to reduce. And there we have it. When I increase the resistance, notice the heat generated per second reduced. And we also understand why that happened. So is that it? Is this what really happens when you increase the resistance? The heat generated decreases? Well, not quite. This is one scenario. Let me give you a second scenario. In the second scenario, let's assume that we increase the resistance, but this time we make sure that the current does not change. We make sure the current does not decrease. How do you do that? Well, if you increase the resistance, you don't want your current to decrease. You have to increase the push as well, proportionately. So let's do that this time. So I'm going to make a copy of this circuit. I'm going to increase the resistance, but I'm going to try and keep my current the same. How do I do that? Increase my push. And how do I increase my push? All I have to do is make my battery bigger. I love digital. Now what's going to happen to my heat generator? Again, pause the video and see if you can answer the question yourself. This time, what has happened to the energy for each electron? Ooh, that energy has increased because my power source has increased. That's the one that's delivering energy to my electron. So the energy of the electron has increased. The second thing, what's going to happen to the number of electrons per second? Well, my current stays the same this time, and therefore the number of electrons colliding per second, that stays the same. The energy per electron, that has increased. And therefore, what happens to my heat generated per second? Ooh, the heat generated per second will also increase. So notice this time, the heat generated per second has increased with your increased resistance. So if you put it together, when I increase the resistance, what happens to the heat dissipated? Does it increase or decrease? What's your answer? Well, your answer should be, Mahesh, it depends. If you increase the resistance and keep your power source the same, the voltage stays the same, then the energy per electron stays the same, but the number of electrons, the current actually reduces and the heat generated reduces. On the other hand, if you increase the resistance, but you make sure your current stays the same, you'll have to do that by increasing the voltage, and when that happens, the heat generated increases. Now, let's build formula for this, and let's see if the formula makes sense. This energy per electron is basically the voltage. That is the voltage. Voltage is actually energy per coulomb, not energy per electron, because energy of a single electron would be so small. So we take a coulomb of electrons, and whatever energy it gains, we'll call that as the voltage. But don't worry too much about that over here. And similarly, what is number of electrons per second? That's the current. Again, current is the number of coulombs per second, not the electrons, but it's proportional to that. And so this is the formula for heat generated, V into I. This is the formula for the power generated, power dissipated, or power generated in any electric circuit. Now, hopefully this makes sense. Now, let's come back over here. Here what's happening is, because my energy per electron, the voltage stays the same, what I can do in such situation is I can substitute for the current. So if I substitute for the current over here, I will get V. And for the current, I'll substitute from Ohm's law. Remember Ohm's law? V equals IR. So for current, I can substitute I equals V over R. V over R. And when I do that, I get V squared over R. And notice over here, heat generated decreases as the resistance increases. It makes perfect sense. Why is that happening? Because my voltage is staying the same. Again, why is it happening? Because when the voltage stays the same, the current reduces. That's the key. That's where it's all coming from. On the other hand, over here, my current stays the same. So what I'm going to do is over here, my current stays the same, but I'm going to substitute for voltage. And substitute for voltage, I get I times R. It's my voltage times R. And I get I squared times R. And notice over here, as the resistance increases, the heat increases. Why is that happening over here? Because my current stays the same. But why if the current stays the same, the heat increases? Oh, because to keep the current the same, my voltage should increase. So the energy of every single electron increases, and therefore they dump more energy into the atoms. And that's why the heat generated increases. So you have now crystal clear understanding of when the resistance increases, depending on which case we're dealing with, how the heat generated can decrease and can increase or decrease.